I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today, I am speaking with Jason Schutter, Applications Engineering Manager at FEMA Corp. Thank you for joining me today. So maybe if you could provide an overview of FEMA's frictionless suspended armature technology, sort of how it works and benefits it offers.
I'd like to say that in the world of electro-hydraulics, and in particular, electro-hydraulic proportional pressure control valves, the key is to control the output pressure, especially in a pilot type valve. And so there's design goals such as response, repeatability, reliability, durability, and life that are key in the solenoid valve design. So with that said, with FEMA's frictionless armature design, the technology is really rooted from servo control valves that were designed for precision control in the aerospace industry. That is kind of the root of the technology. FEMA Corporation has designed a force motor technology from that servo control technology itself. It really consists of a low resistance coil, a steel armature, and that armature is suspended by two very thin flat springs. And so the flat springs provide a point contact within the armature, and the armature and flat spring assembly provide kind of a rectilinear motion. So when the solenoid or the valve is powered, that creates an electromagnetic field, and the armature then in turn can move based on that force that's generated from the motor, and that armature is essentially suspended inside the motor. The benefits of that are really the radial gap inside the motor allows for frictionless control. So the armature, which is the only moving piece in the motor, has no surface-to-surface contact. And with that, that allows for essentially a very repeatable output for a pressure control valve. In applications, many times there's small contamination in the oil or silt in the oil. And if that is present, that can float freely inside our motor so it doesn't disturb the motor's performance. So when we talk about frictionless technology, and more particular FEMA frictionless motors, that's essentially what is going inside, or what's going on inside of the motor.
And so is this a technology that is then utilized in all of the company's products or only certain products? Or could you maybe kind of talk about how or when it's used?
The technology itself is used in many of our products. There are applications where there's more on-off type technology, and usually that motor style is not used in on-off products. But for precision control valves, what we do is we evaluate the application in the system. We look at does that provide a stable output, and we look at some of the design requirements of the valve. And
so then maybe, I know you've kind of briefly touched on this, but maybe sort of if you could talk about what makes this technology different or unique compared to maybe are there other similar technologies in the market, or how does this technology differentiate FEMA Corp's products?
Yeah, so there are many different types of proportional pressure control valves and pilot operated style valves. Many of those use a motor that includes an armature, but that armature is guided inside the motor. It could be a bearing, it could be a tube that guides that armature. With that, there is a surface-to-surface contact that exists inherently in the design. And so that's a friction source. And so what many people do in the industry is they use a low frequency signal to, and sometimes that's dither controlled, to excite the armature and provide a small movement to overcome that friction. A disadvantage of that approach is that low frequency signal can sometimes excite the hydraulic system, and that can result in pressure instabilities in circuits. That is one of the differentiators between the FEMA suspended armature technology and maybe more traditional pilot operated pressure control valves.
And so you were mentioning before that this technology came from the aerospace industry, but I know it can be applied to heavy duty off highway equipment. Can you maybe give some examples of the types of equipment or systems in which the technology might be best suited or would be applied to?
This is a motor design, and this motor is included in a pilot valve. And so the pilot valve is designed to control a pressure output from the source. And so that pressure times an area of a spool, let's say, creates a force that drives the spool. And so this technology can be incorporated in proportional flow control valves, proportional pressure control valves. And in terms of applications, there's a very wide range. Fuel controls, construction equipment for hydraulic brake retarding systems, for clutch controls. Many times there are clutch swaps that occur in transmissions, and some are more sensitive than others. And this precision control technology really can change the vehicle's performance and improve the performance for the operator. Other applications in the proportional flow control could be steering cylinder control. And with this technology, I mentioned braking and steering, those are safety critical, right? And very important features. So the pilot valve itself can provide, again, that very repeatable output with low friction, and in turn create high driving forces that allow the valve to perform very robustly. The technology itself for FEMA, we have millions in the field in many of those applications I just mentioned, some over 20 years of life, so exceeding a lot of the equipment that it's used on.
And now, is this a technology that would maybe be beneficial as, vehicles are becoming more hybridized or electrified? Would this be a technology that would work well in those types of vehicles as well?
This is an electro-hydraulic valve, right. So it does operate in hydraulic systems. Typically, the higher horsepower equipment require operation in high torques, high loads, and with the power density of hydraulics and electro-hydraulics, we see that technology going forward in the future.
Well, those are all the questions I had for now. I don't know if you have anything else you would like to add about the technology or thought our audience should know about it.
I would just add that for proportional pressure controls, it's important to provide that type of reliability and repeatability in systems that are both in open loop control systems and also in closed loop control systems. So again, I think I would add that as a point of consideration.
Okay, great. Well, thank you very much for taking the time to speak with me today. I appreciate it.
Absolutely. Thanks, Sarah.